Okay, so for 10.1 today, starting a new chapter. It will be our last chapter, by the way. Woohoo! Because we'll have a few more weeks. All right, so we're going to define and illustrate geometric transformations, define and perform some reflections, and determine the coordinates of points reflected in the x or y axis. All right, so some things we need to focus on first is some vocabulary. We have the pre-image. Okay, so that's the geometric figure before a transformation. Okay, so there's lots of different transformations. We have a reflection is a transformation, a translation is another transformation, and a rotation. Okay, so there's really three. Yes. Okay, so the pre-image, okay, is the first one. Okay, so this is the pre-image here, and we're going to flip it. So triangle ABC is the pre-image in all of these. Okay, so pre-image. All right, then the image, okay, is the geometric figure after a transformation. Notice it's named like triangle A prime, B prime, C prime. And it says it's how it's read, but the apostrophe is a prime. It's the second one. It's what we did after. So this one, okay, so the red ones here are going to be the image. It's not hard. Okay, so this one we just moved it over in a translation and then a rotation. Okay, so the red ones are the image. So the pre-image is like the original. The image is the secondary one.
Oh, that's why it has a prefix pre.
That's why it has the prefix pre. Okay, good. All right, so then it says you might read the word map in there. Okay, so map is like where it says, well, triangle ABC becomes triangle A prime, B prime, C prime. Or it could be triangle ABC becomes triangle XYZ. But each transformation describes a correspondence between point locations before and after the change. So it maps the pre-image to the image. What that means is like A is still linked to A prime. Okay, it's mapping it. B goes to B prime and C goes to C prime. That's a little trickier in this one. Triangle ABC maps to triangle XYZ. So what point corresponds to A? A goes to X, B goes to Y, and C goes to Z. Okay, so that's all that mapping means, is they go to each other. Like A and X are the same, like they're corresponding points. Okay. Questions so far? Okay, so example 1 says name each point or set of points if R at triangle RST maps to triangle XYZ. So what's the image? What's the corresponding part or point to the image of R? X. How about the pre-image of Z?
T.
Don't answer the next one. How about the image of R triangle RST? You got it. It's triangle XYZ. It really is that simple. Like, we just want to make sure that you understand what it's saying. Okay, perfect. Then, all right, reflection. A reflection flips the pre-image across a line to produce a mirror image. Okay, it can be a lot of different lines. That line, though, is called your line of reflection. If you remember in the objective, it said we're going to focus on the x-axis and the y-axis today and flipping them. All right, so the line of reflection, though, acts as a mirror to create the image. So our line of reflection here is right there. Is this a horizontal or vertical line of reflection? Horizontal lays down with the horizon. So it's vertical, right? Okay, so
That's a little squiggle.
it has got a little squiggle. Not really a line, is it? All right, it says notice the line L is the perpendicular bisector of any segment connecting a pre-image point to its image. What that's saying is from here to X, and from the line to x prime is the same distance, right? Because it's a perpendicular bisector. So the distance from the bisector to z and from the bisector to z prime, those are the same distance. You probably did do it in summer school, okay, or something. The distance from the line of reflection to y and the line of reflection to y prime is the same. Okay. Which means, in example 2, it says reflect LMN in line K. So we're going to reflect it over line K. So we need to measure. You need your ruler. You're going to put your ruler up there and measure. I'll have to write it on. Okay. It doesn't matter. You can use, as long as you're consistent with it. So if I put it up there and measure, my M is on the board is 3 millimeters, right? From here to here is 3 millimeters.
What?
Okay, mine is larger. Sorry, 3 centimeters anyway. But you have to think mine is enlarged.
About to say yours would have to be smaller.
So then I would have to go the other way and draw a line of equal length, put a point there,
Half a centimeter.
and label that M prime. Right, because they're equal distance from the line. So the same way with L, I would measure L. The distance from my line to L,
What?
okay, and then I would go the other way. And put my point and label that L prime. And then do the same thing for N. Okay, so from your line of reflection to point N, make the same line on the other side, the same distance. Put your point, label it N prime. All right, and we're going to pause for a moment to have our class prayer, and then we'll be back. All right, once you have all 3 of your points reflected, okay, use your ruler, and you can connect your points to make your reflected image.
Why are you doing that?
That one got a little off here.
Mine looks good. What about yours?
Okay. So it's harder to do on the screen. Which of these is the pre-image? The first one, right? This was the pre-image. They gave it to us, but it's considered the pre-image. So then the L prime, M prime, N prime is considered what? We have a pre-image and an image. So this one is the image. Okay, great. Now, the cool thing is we can also do this on a coordinate grid, which is my preferred way to do it, quite honestly. All right. So it says, given triangle PQR with P at 3, 4, Q at 1, 0, and R at 5, 2, find the reflection of PQR in the x-axis. Okay, so let's graph it first. And you need to label. So P is 3, 4. 1, 2, 3, 4. And label it P. Q is 1, 0. And R is 5, 2. Okay, you can go ahead and connect those points. It does kind of look like a slice of pizza.
What? And cheese?
All right, where are we reflecting it?
The opposite?
No, in what axis?
X.
In the x, okay? So we want to reflect it across this x-axis, which means we want to know how far is it from like R How far is R from the x-axis?
5.
R.
2.
2. So it's 2 up. So we want to go 2 down and put a point, and we would label that what? Yeah, because we're reflecting it in the x, so across the x-axis. Not P, I'm not on P.
R with a little 1.
R with an apostrophe. It's R prime. Bless you.
No.
Okay, I won't bless you then. Okay, if we look at P, how far is P from the x-axis? 4 above. So we need to go 4 below and put a point and label that what? P prime. P apostrophe. P prime. Okay. How about Q? Bless you. How about Q? It's on it, so it just stays on it, right? We can't reflect it across. So we'll put a point there and label it Q what? Prime. All right, and now you can connect those points to get your image.
You slow.
Yeah, I finished this while you were still talking. Look, we have 3 slices of pizza now.
I thought this week was supposed to be Teacher Appreciation Week. You don't sound very appreciative at all.
They're mean.
Apparently.
Shut up, Lucas.
Get us ice cream and we'll appreciate you.
No. That's not what appreciation means. All right, so we have a pre-image in pink, and our image is in red. Okay, make sure you label them as well.
I'm pretty sure it's called Teacher Needs to Appreciate Week, not Teacher Appreciation Week.
Maybe
False.
a student appreciation day. That's what we
Nobody cares about students.
Exactly. How's that fair?
I think you all are sadly misconstrued.
Prove it.
You are appreciated every week.
We only need 4.
Okay,
We don't have that many days left of class.
We need 5.
if you want Teacher or Student Appreciation Week, I can sit down and you can just read the book and do your notes.
That's dumb.
Will we
Well.
have any more homework days? Will we have enough to get to 60?
I don't know. All right, example 4 says find the line of reflection for the illustrated reflection. So which one of these, so we just have 2 lines. Which one of these is the image and which one is the pre-image?
Oh, the B to the A.
B to the A is what?
One of those things you
The
just
pre-image.
BA, okay, is the pre-image, yes.
And then the A prime, B prime is the image.
All right, so,
see the prime on there.
I barely saw it.
okay. So we're looking for the line of reflection. Where is the line of reflection?
Oh. You have to measure it.
You don't have to measure it,
Yeah.
okay?
I thought it was when it crossed over.
When it crossed over what?
Look,
It crosses through each line.
I'll just draw
Okay, you draw it. Like where would the line of reflection be? Right, like that's the same thing as like where's the mirror image?
Go here.
Like if I had a heart,
You better break that
okay?
'cause you don't have one.
Where's the line of symmetry?
Go in the middle.
Through the middle. The line of symmetry, the line of reflection are similar concepts
Diagonally?
because,
Is it this way?
is it diagonally like here?
Yeah, or is it the other way?
Well, if we drew, so like let's see, if we drew a line here, is it reflected across that line?
No.
Nope, that's not it.
So it's the other way. It's this way.
Is it this way?
It's not right there though. It's right there.
Right? Are those reflected? No, those aren't reflected. Like where are they reflected?
Right there.
Okay, good.
Across the room.
Right,
That's
what?
I've been saying.
You're,
They're the middle like this. That's what I've been saying.
I know, I'm working on it. I'm getting there. I'm showing some non-examples. So through the middle,
Draw it. You should have drew it. That's crooked.
a little bit, it's okay.
That's a lot of it. It didn't even go through the center.
Okay, I'm done. You can do example 5 on your own.